In section 4.1 we looked at the triangle sum properties, and this is really our introduction to triangles. Before we start looking at the angle properties that we're going to have, we have to make sure we're able to identify triangles in two different ways, by their angles and by their sides. If we're looking at their angles, we have what we call acute triangles. And acute triangles will have three acute angles. Now an acute angle is anything less than 90, so if all three angles are less than 90 degrees, we call it an acute triangle. The next one we have is when we have one right angle, and we call that a right triangle. Our third one is where we look at this angle and see that it's obtuse, and when we have one obtuse angle, we call it an obtuse triangle. The last one we have is when we're looking at all three angles being equal. Now this is not really different than the three we have, this is kind of an exception of it, and this is what we call an equiangular angle, equiangular triangle. And we're going to talk more about that later in this chapter, but if actually we can classify it in one of these, it's just an acute triangle where all the angles are the same. When we identify by sides, the first one we have is when we have no congruent sides. When we have no congruent sides between the triangle, we call that a scalene triangle. If we have two congruent sides, we call that an isosceles triangle. And lastly, when all three sides are congruent, we call that equilateral. So, those are how we can identify. Let's get to the big theorem of this section, which is the Triangle Sum Theorem. And that says the sum of the measures of the interior angles of a triangle is 180. Anytime I have a triangle, the angles will add to 180. That's the rule we're looking at here. So it could be acute, obtuse, right, equilateral, equiangular. It could be scalene, it could be isosceles. It does not matter. As long as it's a triangle, the angles add to 180. So typically what we're going to see here is you're either given two angles and you need to find the third, or you have some combination of x's and values and you have to solve, like we have below. So if I wanted to solve this one on the left, I could say 66 plus 2x plus x equals 180. That gives me 66 plus 3x equals 180. If I subtract 66 from 180, I get 114. And then divide 114 by 3, and we get 38. So if x is 38, we could then go back and check to see what each of our angles were. By plugging it in, I'd get 38 here. And 2 times 38, which is 76. And we could check 76, 66, and 38 to make sure they add to 100, make sure we did it correctly. And it does come out to be 180. So we found x correctly. X was 38. We could then plug it in, find the angles. We could even identify what type of triangle this is. Since all of those angles were acute, that would be an acute triangle. Next, we can go up to our one on the right here, and I have x plus 110 plus x minus 10 equals 180. That gives me 2x plus 100 equals 180. I get 2x equals 80, so x equals 100. When I plug it back in to find the 100, got ahead of myself here, it gives me 40. When I plug it back in to find each of the angles, I get that this angle is 40, and this angle is 30, and if we look real quick, we get 40, 110, and 30 do add to 180, so we know that fits, and this would actually be an obtuse triangle. Now the next one we have is the exterior angle theorem, and this tells us that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Now if I'm looking at my triangle here, I know I have my interior angles. Let's label them A, B, and we'll put C right here. And let's say I'm looking at an exterior on the outside. An exterior angle is going to be next to the interior angle. They're what form a linear pair. So if I'm looking at what this says, I'm saying that the measure of angle A plus the measure of angle B is going to be equal to the measure of angle E, which is this angle out here. Because A and B are not next to E, and A and B are both inside, so that's going to be the same. Now, realize also that angle ACB, which is right here, plus the measure of angle E, I should put an M out in front, equal 180 because they're a linear pair. So I could also use that fact to help me solve, to find it, but it's just some relationship that does exist. Now, there's a few ways we could look at it, looking at the one on the bottom left. Here I would likely say that 84 plus 56 equals X. I then can combine them, and I get that 140 equals X. Now, that's the measure of the exterior angle. If we wanted to go back and check, this angle would be 40, which would fit into making the triangle to be 180. So actually I could have found 40 first by treating it as just interior angles, and then subtracted that from 180 to get 140 as well. For this one, we could on the right we could do 140 equals 2x plus 80. We then get 60 equals 2x, so x is 30. So those are the basic properties. Now let's go through and start solving some problems. So if I look up in the top right, I need to find P and Q. Well, at first, P and Q are in the same triangle with a 98 degrees, but I don't have enough to solve there. I actually have to use what I have on the left triangle, the triangle on the left, to help me work my way to it. So I could do 82 and 31 together give me 113. I could subtract that from 180 and I get 67, which is this angle. Now, isn't that angle the same as angle P because they're vertical? So that tells me I have 67 for P. And then when I want to find Q, I can do 67 plus 98 and get 165, and then subtract that from 180, and I get 15 for Q. Okay, we go over to the top right, looking at this angle, and I have two angles that are the same. So actually they're both M. So I could say 35 plus M equals 180. 35 plus 2M equals 180. That's 2M equals 145. So M is either 145 over 2, or we could just say 72.5. Now in the bottom left, we have to take a little bit different approach to this one, because yes, we have two triangles. I have one on the top left with the A and the 79 degrees, and I have the one on the top right with the 50 degrees, but we have to do some extra work before we get there. Now, we have parallel lines here, so that means these are alternate interior angles, so I actually know that I have 23 degrees right here. Let's make that a little clearer, 23 degrees. So since that's the case, I could do 23 plus 79 gives me 102, and then subtract 102 from 180 and get A is 78 degrees. Now, furthermore, I can take that B and move it up to its alternate interior. And then I have 50 in B, and I need another angle. But 79 and the angle next to it are a linear pair, so that would actually be 101. So 101 plus 50 is 151, and then we subtract that from 180, and we get 29 degrees. Our last one, for the bottom right, we're going to have to solve for x first. So I look at all the x's, they're inside the triangle. So 100 minus x plus 30 plus 4x plus 7x equals 180. So we get 130 plus 10x equals 180. That gives me 10x equals 50. So x is 5. Now, I'm going to plug that in to all my angles just so I can see what I have to deal with. And so I get 35 here, 95 here at the top. 30 plus 4 times 5 is 50. Quick check to make sure that adds to 180. 50 and 35 is 85, plus 95 is 180, so I'm good there. Now to find y. Two options. I can either take 135 and subtract it from 180, because they're a linear pair, or I could add 50 and 95 because it's an exterior angle. In either case, I get that y is 145 degrees.